Lesson 4.14, Direct Variation. So today's lesson is all about direct variation, which is really just a fancy way to talk about proportions. First of all, if we want to look at the actual definition here, we're going to say if y varies directly with x, when x changes, the y changes in proportion to x, right? I mentioned just a second ago, right? This is really just talking about proportions. The equation, we call it y equals kx, where k, right, that number in front of the x, the slope essentially, we call that the constant of variation. Okay. And then finally, k can be found by the following equation. Well, I mean, we can find the equation from this one, right? If I want k by itself, won't I just divide both sides by x? So the equation for this is going to be k equals y over x. Just like slope, right? Y is always on the top. Y over x. Before I really start to get into some really specific examples, I just want to kind of show you in general, what does this look like? All right. This graph on the left is an example of direct variation, right? The one on the right is not an example. What do you notice? Okay, hang on to that. Let's look at the next one. Okay, again, the graph on the left is direct variation. The graph on the right is not direct variation. Are your observations holding up under this new example? Okay, again, hang on to those. Let's look at the next one. Now we have it from a table. The top one is a direct variation. The bottom one is not a direct variation. Do your observations still hold up? Okay, and then this one is talking about a word problem. Okay, it is a direct variation example if we're talking about a hot air balloon ascending from the ground at a rate of 60 feet per minute. It is not a direct variation example if you say that we're dropping a rock from a bridge that is 100 feet high. Okay. Any guesses about what direct variation really is? Well, essentially, y'all, it just means that it goes through the origin. It means that it's always going to start at 0, 0. Because if it always starts at 0, 0, then the y divided by the x is always going to be a constant, right? And that's kind of what we talked about earlier when we called it k. All right, so let's look at a couple of examples here. All right, let's look at the first one. We're supposed to determine if it is direct variation. And we do that by determining if it goes to the origin. Well, we can't really see if it goes to the origin, can we? Maybe if you plotted all these points you could, but a quick way to check is just to divide y by x. So negative 7 divided by negative 4. And because I know that's not going to be a nice number, let me just check and see what that number will look like in my calculator. And we get 1.75. Okay, so I'm getting 1.75 when I divide y by x. Okay, well, what's 5 divided by 2? Let's see here. 5 divided by 2 is a different number, 2.5. So that means that no, right? Because this is not constant. A direct variation, these will all be constant. All right, so we're going to say NA here, right, doesn't apply. We could get the equation actually. Let's get the equation just to kind of prove to ourselves what's happening here. I'm going to go to stat edit. All right, and I'm going to type in my numbers here. I'm going to type in, let's see, negative 4 and 2 and 4 and 7 over on the right. So let's see, I've got negative 7 and 5 and 9 and 15. Okay, I'm not really sure why I skipped the last entry. Let me just type it in here, 25. So on the left, we got to put that 12 in. All right, so what's my equation here? Stat edit, stat calc, option 4. Click enter a bunch of times. All right, so we're getting the equation y equals 2x plus 1. Okay, kind of makes sense. It's not direct variation, right? So I'm going to say does not go through the origin, right? This has a y-intercept of 1 instead of 0, so it's not going to be direct variation. It's still linear, it's still a good function, it's just not direct variation. All right, let's try the next one here real quick. Negative 6 divided by, negative 12 divided by negative 6 is 2. Negative 4 divided by negative 2 is 2. 8 divided by 4 is 2. 22 divided by 11 is 2. And 30 divided by 15 is also 2. So I know this is direct variation. K is 2, right? Everything's getting multiplied by 2. And this makes my equation writing super easy because I get to just say y is equal to 2x. I don't need to write plus 0, right? Because it's direct variation. It's going through the origin. I just have my equation here. Now, of course, if I want to do stat edit with this table, I absolutely could do that. It would tell me A is 2, and it would tell me B is 0. All right, let's look at the next kind of examples. We kind of already touched on this. Determine whether each table represents a direct variation. That should say graph. Okay. If it is, find the value of K and write the equation that would meet the situation, model the situation. All right, in this first example, it goes through the origin and it is linear. So yeah, I know the equation is direct variation. So I'm going to say yes, direct, I'll just put direct V, okay? So my equation is going to be y equals kx. In other words, what are we multiplying by? Well, it's honestly just slope. What's my rise over run? Up 3 over 1. So this equation is going to be y equals 3x. Let's look at the next one. All right, this intercept is not at 0, so I'm going to say no, not direct variation. And so we don't even have to write this equation. I mean, we can see that it's y equals down 4, right 2. So my slope is going to be negative 2x. And then my intercept is that positive 1. But it's not direct variation. It's not this really special kind of linear function. All right, let's keep going. All right, what if we don't have a table, we don't have a graph, we just have these basic equations? Well, don't overthink it. It's really not supposed to be too bad. In this first equation, is this direct variation, y equals 2x? Well, does it have a y-intercept of 0? It does. So it is going to be direct variation, and k is the slope, just negative 2. 6 is a direct variation. This one's a little bit trickier. We don't have x. If we're not sure what this line looks like because it's a little bit weird to us, go ahead and go to y equals in your calculator and just type in y equals 6. And you can graph this thing and see, oh, okay, this is the horizontal line. This is not direct variation. It doesn't go through the origin. All right, so we're not going to really worry about k. On this next one, we have the slope. We don't have the y-intercept, which means I know it's 0. I mean, again, honestly, if you want to just type this in your calculator each time to see it, it's not a bad plan here. All right, yes, this is going to be direct variation, and k is 4. And finally, is this one direct variation? Well, we can see clearly that the y-intercept is going to be 4. It's not 0. So it's not direct variation. All right. Now this is one, example number 4 is what I've seen most often on tests. So I really kind of want to talk about it here real quickly. It says if y varies directly with x, I really need you guys to understand that this is just saying y is proportional. It's just saying it's proportional. All right, and then it tells you, okay, when y is 10, x is 5. So what is the value of x when y is 7? Again, set up a proportion. Direct variation means everything's proportional. So I'm going to remember that it's always y over x, and I'm going to use these. All right, so 10 over 5 is equal to, there's my proportion. All right, what is x? So I don't know x when y is 7. And at this point, all I have to do is solve pretty simply. I hope you remember we can just cross multiply here. So I've got 10x is equal to 7 times 5, which is 35, which means that x must be equal to 3.5. All right? And that kind of makes sense if you think about it, because 10 and 5, isn't that half? Isn't 5 half of 10? So if I know that y is 7, wouldn't x be half of that, which is, yeah, 3.5, right? Should kind of all click here. All right, example number 5. The value of y varies directly with x. Okay, again, this just means proportional. Right, this just means proportional. Which function represents the relationship between x and y if y is equal to negative 18 when x is equal to 3? So this time we can't set it up like we did earlier because we are not just missing a single value here, we're actually trying to come up with an equation. And so we have to understand that if they're telling us that y is negative 18 when x is 3, and we know it's directly proportional, then we need to remember that k is going to be equal to y over x. I mean, look at all my answer choices. All I have to do is figure out which of those numbers is supposed to go in the front. And we're going to divide y by x. So we're going to have negative 18 divided by 3, which is going to be negative 6. So my equation would simply be B. All right, finally, example 6. The mass of a substance varies directly with the volume of the substance. So I'm going to call mass M, I'm going to call volume V. The volume of 100 kilograms of the substance is 80 liters. All right, so the volume of 100 kilograms is 80 liters. So I'm going to go ahead and write the volume is 80. Let's see, what is the volume in liters of 3.2 kilograms of this substance? You know what? Let's think about this a little bit of a different way. Do you remember how we always say y varies directly with x? That's our phrase, right? Y varies directly with x. So instead of calling this M and V, the y is going to come first. So the mass of a substance we're going to call y. The volume of a substance we're going to call x, right? Y varies directly with x. So let's go ahead and let's kind of set up what they gave us. The volume of 100 kilograms, all right, 100 kilograms is mass, right? You should know this from your science classes. Kilograms is mass. So we're going to go ahead and we're going to remember that y over x is how we set things up. And 100 kilograms is mass. All right, so 100 kilograms is going to give me 80 liters, right? Mass over volume, y over x. And then it says, what is the volume in liters of 3.2 kilograms of this substance? All right, well, 3.2 kilograms, again, that's mass. And so that's going on the top. So we're going to put on the bottom, we're just going to put what we don't know, which is x or v if you want to call it that. So I'm going to go ahead and I'm going to solve for this thing. We've got 100x is equal to 80 times 3.2. So 80 times 3.2, which gives me 256. So if I'm going to divide and get that volume by itself, we're going to get 25.6. All right, so we actually just essentially did all the work here. All right, we got 25.6. We didn't even find K. We didn't even write an equation. We just went ahead and set it up as a proportion and solved it. Now, if you wanted to do that, remember how it's y over x, like this is equal to K. So if I wanted to have found K, I could have just put 100 divided by 80, right? 100 divided by 80 is going to give me, let's see here, 1.25. So I guess K was 1.25, which means my equation would be y equals 1.25x. And if I wanted to use my other variables, for example, if I wanted to do mass and volume, I could say that the mass is equal to 1.25 times the volume, right? And we could have solved this a little bit differently had we wanted to. All right, guys, the biggest takeaway from this lesson is two things. Direct variation always goes through the origin if you see it on a graph or in a table, right? Or even just an equation, right? It's not going to have like a plus a number. And finally, if you get a word problem, set up a proportion. I cannot stress that strongly enough.